How long could you survive after taking off your helmet on the moon? Here is the moon, and this is our astronaut. Supposing for some reason this astronaut decided to remove his helmet, what would happen? One might think that the sensible action to take before entering a vacuum such as that of the moon would be to hold one's breath. Doing so, however, would almost certainly prove to be disastrous. Under normal conditions, the atmosphere surrounding the human body exerts a pressure on the lungs. When this pressure is removed, the expansionary force of the air in the lungs is greatly increased, causing the lungs to expand rapidly. In reality, however, you are almost certain not to explode. The skin and soft tissue of the human body perform very well as a container for internal injuries. Instead, the air in the lungs would be suddenly and brutally expelled through the airways. As well as destroying the respiratory system, the air rushing from nose and mouth would have a cooling effect, bringing the temperature of the astronaut's face down to near freezing. So now we know, before entering a vacuum, do not inhale breath but exhale. Exhaling air is clearly going to bring into play a number of new problems. Without a supply of oxygen in the lungs, the level of oxygen in the blood will quickly be depleted, the brain will cease to function, and the heart will gradually slow. Although the average astronaut could probably hold their breath for a minute and a half, with empty lungs it is estimated that a person would be unconscious within 12 seconds. Most people will at some point have heard that the body is made up of about 60% water. Some will also know that under vacuum conditions, the boiling temperature of water is reduced. This means that when exposed to a vacuum, up to 60% of the body is at risk of evaporation. At first, this effect will be limited to the outermost moist surfaces of the body. Our astronaut will experience a tingling of the tongue, for example, as saliva is boiled, evaporated and transferred to the atmosphere as vapour. As time goes on, the same effect will be felt inside the body, but as the vapour has nowhere to go, the body will double in size as bubbles of steam push outwards on the skin. All the while, our astronaut is unconscious and air continues to flow from within him. By now, it should be fairly clear that our astronaut's chances of survival are slim, but just to be sure, even if he did happen to be within 6 seconds crawl of his spaceship, or if he was with a friend who was able to drag his unconscious body to safety, and assuming that his lungs weren't permanently damaged by the decompression, the moon dust kicked up by his struggling may also prove fatal in the long run. Due to the fact that there is no wind, rock particulates on the moon are not smoothed like sand on Earth's beaches. Lunar dust particles are in fact very sharp and abrasive and potentially dangerous, which is incidentally why so much research must be done on astronauts' boots, but that is another story. Should our astronaut ever make it back to Earth, he is likely to suffer damage to his eyes and internal systems. In summary, if you chose to take off your helmet on the moon, you would be unconscious in 6 seconds, and if you were unable to return to safety within the very generous estimate of 60 seconds, your chances of survival would be reduced to 0.